Hey everybody, welcome to Data Engineers Lunch number 23. Um, Almost to the 6 month, probably beyond the 6 months that we've been doing this. Today's topic, I'll be talking about Thanos and Cortex. It's actually a follow-up on a talk that Will gave last week. And it's if you weren't here last week, we have the videos and blog posts um, on our website, blogathonot.us, or it will be there shortly. Yeah, there it is. And all the videos are also available on YouTube. Looking for volunteers to help. We're also looking for speakers if you're interested in speaking about any topic related to data engineering. As you can imagine, data being the blood of the enterprise, of any decent sized organization, or actually any modern enterprise, data engineering is a big part of today's business. If you want to be a co-organizer, you'll be able to help out beyond just being a speaker, obviously, but get to really meet some interesting people. And then you're part of a larger data community DC ecosystem of organizers and meetings, meetups. Data community DC is basically user group meetups that are generally around data. And it's a nonprofit that we all kind of collaborate on together. Especially if you're young in your career, this is a great way to network and build up your connections in data in the DC area. What we cover here, we cover the get your shit together problem. How do you get all the data together? How do you clean it up? How do you organize it such that people can actually use it? So going from raw data to usable information is what data engineering is all about. And there's a lot of different ways to do it, a lot of different programming languages to do it. So we don't really cover one particular technology, architecture, or programming language. We try to really be as diverse as the audience is. Anybody new to this Data Engineers Lunch that just wants to say hi and what you do with data and what you want to learn or what you could talk about potentially? Okay. Don't see any raised hands or on the chat, so that's quite okay. Group rules: if you have a question, especially with me, just ask it. You can do it on the chat, but sometimes I don't see it, so just drop in. I won't take it personally. Use that as an opportunity to say something that may add on to the conversation. So it's not just a question, just talk. Our company Anant helps people build very large-scale global platforms, especially with Cassandra, Spark, and Kafka. So data engineering is a part of our daily life. DataStax is a partner and a sponsor. So is GW University. We have a few local sponsors, and as well as some institutional sponsors for the larger data community DC nonprofit. Any announcements around data? Anybody looking for work? Anybody has jobs to offer? Okay. Well, we're hiring, always looking for qualifying operators, engineers, and architects. We generally have work in full-time or even a part-time capacity, depending on the client. Don't really care where you work. You could be in Antarctica, as long as your internet's good, we're cool. Data events, upcoming next week is Pandas for data engineering. And then the Cassandra lunch, which is Wednesday, will be Spark SQL for Cassandra data operations. And then the following week in Data Engineers Lunch, covering Airflow and Spark. This is obviously every Monday, and then every Wednesday there's Cassandra Lunch if you're interested. More events on Data Community DC, and let's see what's coming up in June. Mathematica. And if you go to datacommunitydc.com, you can go to any of the meetups from there. So let's say blockchain DC, data visualization usually has something. We're data runners DC here. So we got blockchain, nothing coming up. Visualization usually has a monthly. There we go. Racial equity, awareness, and data visualization. Cool, interesting. And then, of course, this is us. All right. Well, without further ado, we'll go ahead and get started with today's presentation. And we've covered a bit of this in another session. I think it was more around what databases use Cassandra, and this thing came up, at least Cortex came up in that conversation. We were looking at different time series databases, but today's topic is really more about how do people generally scale Prometheus for global platforms that doesn't even have to be a global platform, it could be a national platform, or it could be a heavily used platform inside a company that has hundreds or thousands of containers, or even hundreds or thousands of virtual machines. But it's not about Prometheus itself. That's actually Will's talk from last week. We'll probably have this as a perennial topic because everybody uses Prometheus. But today we're really talking about how does Prometheus scale, and maybe a little bit about why we can't really do Prometheus at scale with Prometheus itself, why it needs these helpers to do what it needs to do. So quick recap, and this is directly from Prometheus website. What is Prometheus? It's a multi-dimensional data model over time. You have metric name, and then you have key value pairs for that particular metric. So it stores that data inside in a thing called TSDB, but it's time series data. You don't really use it for arbitrary information. I guess you could, but it doesn't really make sense. There is a Prometheus PromQL a standard query language that you can use to query data from the API, REST API, if you'd like. And so this is one of the things we'll talk about is, so PromQL, because it's a standard, technically anything could be running in the inside of the system. As long as it supports PromQL, it's Prometheus-like. The data can be collected via pull. So there's like an agent that just kind of pulls data from these different systems that you may want to monitor. And what is it that you could be monitoring? Well, anything, any service that's running, you want to collect information about it. You could even put stock prices in here if you'd like, right? It doesn't really matter. It's just time series information or blockchain price information, or you could push data into it using the gateway. Cool thing, because we're generally doing large scale deployments, the system can dynamically discover what needs to be monitored. So if you're scaling up pods, it'll determine that there's multiple instances, and it will start to take information from there. Or you can obviously you can statically configure it to do exactly what you want. The main separation is that there's collecting data, and then the graphing and dashboarding is really done with Grafana, but that calculation of what needs to be sent in the code is separate from how the data gets stored and compacted versus how it's queried and then sent for graphing. And we'll actually see how, when we do this at scale, how these other systems have to deal with that when we're getting to a larger scale. Prometheus, you can deploy it on anything really. You don't have to do it on Kubernetes, but in my experience, normally I've worked with it in Kubernetes, done a bit of it in virtual machines, but generally Prometheus is there in virtual machines because there's no other existing system to monitor something. But generally, when we're working with virtual machines, there's something else that's monitoring the platform. So I don't really have to worry about it. So when we get to Kubernetes, there's like a variety of stuff that needs to be orchestrated and managed, and then Prometheus helps get this view on what's happening. So as I was mentioning, the main Prometheus server, basically it collects data, puts it into a time series database, which is a way to store data. It's kind of like SS table format, which a lot of different databases use that concept of an SS table. This thing, TSDB, we'll see later, is used by some of the other systems as a format. And then, of course, there's the HTTP server that allows people to query and push alerts. We also have webhooks, and you can also have a push gateway where other systems push information into Prometheus. This is a little simplified version. Systems run, Prometheus runs on Kubernetes. It collects information, and ultimately people use Grafana to interact with it, or they can get alerts on Slack or on webhooks. But you don't really go into Prometheus on the command line and do stuff. It's generally through this external tools. So things that we're going to look at today. We're not going to look at M3DB, Victoria Metrics, and Vulkan. Although M3DB would have been probably a good one to look at. These are the main kind of known Prometheus at scale. There's another one called PhiloDB, which runs on Spark SQL and on Cassandra. But these are the most popular ones. Cortex and Thanos being the ones we're going to talk about today. M3DB from Uber is used by a lot of big companies as well. All of these are open source projects, by the way. Vulkan is no longer active. It was another Prometheus compliant system running on top of Cassandra. And then Victoria Metrics, I'm not sure exactly what their technology is, but it's yet another Prometheus variant at scale. The reason I chose these two, we'll get into, but ultimately, people talk about Cortex and Thanos, and we'll see why. So what is Cortex, Thanos, M3, Victoria Metrics? And by the way, Sysdig has like a commercial version of their own system. These are long-term storage for Prometheus. So you still have Prometheus kind of sitting next to your services, right? That doesn't go away. You still need to have Prometheus. So what these systems do is give us a way to have the data for long-term storage and to scale. If these containers go down, we still have that information. Or if this one or two Prometheus services go down, this Prometheus service still continues to put data into the long-term storage. And from Grafana, from the end user perspective, nobody's the wiser, right? What happened? So what do we need in terms of Prometheus at scale? So generally, it's a global view, getting data from multiple Prometheus instances or Promethei. No downtime, no data loss, so multi-replica, high availability. Long-term storage is one of the core needs, right? So if you want to look back into the past, or really looking back into the past in the future, right? You want to collect data for a year and then in the future be able to see what my trends are on different services. That's why we need long-term storage. The things I added to this are my own kind of needs of Prometheus at scale. So global scale. Can this thing work at global scale? And what global scale is not just where it sits, it's the amount of information. Can I continuously keep scaling it? Can I continuously keep adding information? And if you've ever been in platform architecture, engineering, or operations, once a platform is up, the logs and the metrics are the thing that make it work. Because being able to see what's happening at scale on a global scale platform is what reduces the downtime and the impact on the business, because we can see signals of downtime well ahead of time. Community support, who's using it, right? So my question was, are a lot of people using it? And so that definitely still applies to M3DB. And you can, I'll pull up the websites in a second, but you can look up M3DB, Thanos, and Cortex, but pretty much a lot of big names use it. And then finally, community knowledge online. And this is the ultimate reason why I chose Cortex and Thanos. There are many more people talking about Cortex and Thanos and writing about it than the other ones. And that's called the network effect. A lot of people use it because a lot of people are using it. A lot of people are using it because a lot of people talk about it. And maybe M3DB in the future can do the same thing. But for now, you'll notice that Cortex and Thanos are really tied together with the Prometheus project. All right. Cortex, in terms of global view, the way it deals with that is it centralizes data. And we'll see that in an architecture diagram in a second. How does it do multi-replica high availability? Well, what it does is when it gathers the data, it dedupes it and it writes it, because you may have copies of information coming in. So it, because you have, high availability system, you have multiple systems basically giving you different numbers that are for the same, are giving you the same information. So you have to kind of dedupe it. So it does that at the right operation. In terms of long-term stories, there's two sets of data that Cortex is using. One, and it also uses memcache for some caching, but essentially there's an index of the data and then there's actual chunks of information. Index of the data is how it's able to kind of query information quickly, and then the chunk is the actual data itself. So Cassandra, Dynamo, and Bigtable are supported out of the box. Apache Cassandra being open source, DynamoDB being AWS database as a service, and Bigtable being the Google NoSQL database as a service. And by the way, so if you're using Cassandra, you can technically use any Cassandra variant. So ScyllaDB, DataStax Astra, you could use Amazon Keyspaces or Cosmos DB CQL. In terms of the chunk, the actual data, it uses those three, but it also can store data into S3, Google compute storage, and Azure's storage engine. Although I think if it's S3 compliant, you could write it to even more systems. Thanos explicitly says they can use other S3 compliant systems like MinIO or Ceph, but I would assume that you could do the same here. Obviously, because these are cheaper to manage than the actual databases. High-level architecture, you have your apps, you have your different systems. Prometheus continues to do what it does, right? Nothing's happening differently. You still need to manage and run Prometheus, but then it starts to write data into Cortex, which has its kind of distributor and courier, and you'll see in a different picture what those mean. And so to the outside world, right, Cortex is just like Prometheus because it's using the same PromQL, right? It's not different to the end user that's using Prometheus. Using Cortex is not anything different. It's just the operators need to keep this up and running, right? And the other thing that's different is that because we're centralizing the data, the alert manager sits inside Cortex. And that can send out your PagerDuty, Slack, or webhook alerts. Going deeper into the Cortex architecture, essentially there's this gateway which you use from Grafana, and Prometheus uses to put data in, right? At the high level, that's kind of what I was showing here, right? Things put data in, things get data out. But how does it do it? So the right path is data comes in. There's some optional systems here, like the alert manager. You need to have a Postgres database. But mostly, it distributes the data and puts it into your various potential, well, if you're using Cassandra, it puts it in the right places. It also puts it into the chunking systems, and it keeps the cache in memcache. And when you query it, it goes to the query front end, it fans out the query. It really doesn't need to fan out the query. That's really done by the database, right? The technology itself takes care of the quote fan out of the query, or it gets whatever it needs. So is this the index? If the data is here, it'll get the chunks from here. Or if you're storing the chunks here as an option in cold storage, it'll get the index, it'll get the data. It may look in the cache, and then it'll bring it back to you. So when we look at the Thanos architecture, it'll be different because it takes a different approach to kind of solve the same thing. But this is done at scale. So Prometheus sends data to many, many potential, pod containers, et cetera, that are then distributing to different ingesters, so that those ingesters put it into the distributed database, which, Dynamo, Bigtable, and Cassandra in their own way will distribute the data in the highly fault-tolerant database. And then the queryers, again, they query from a highly fault-tolerant database. Those database technologies kind of figure out where the data is, they bring it back. And no one's the wiser that you kind of replaced this direct interface to a brittle Prometheus with a really highly scalable multi-tenant Prometheus. Now let's look at Thanos. So Thanos takes a different approach to the global view. It federates the data, as in it is sitting next to the other Prometheus services, right? And so when you query data, it brings it from those Prometheus servers, right? In Cortex, that's being done by the database technology itself. It brings it together, and it starts to replicate that data into an object store. So when it reads the data, it dedupes it at the query time, and then it saves it into long-term storage in the native format that Prometheus is storing it, right? So it just takes the TSDB data, does some compactions, it does some other stuff, which many databases do, and it stores it in Google Compute, S3 compatible system like Ceph or MinIO, Azure Blob Storage, and there's like a whole list of you can do it on Tencent or Open Stack Shift, excuse me. But it looks similar, right? At the top level, you're like, yeah, okay, I get it. It does it slightly differently, but ultimately in the architecture, it's Thanos in the background doing everything. Just kidding. Sorry. I love comic book movies. So basic architecture for Thanos is you've got your Prometheus running as you would expect, right? Nothing changes there. Just like Cortex, it's going to be running in the background. It's there. And right next to Prometheus will be a Thanos sidecar. It's kind of redundant, right? So Prometheus is commonly a sidecar to many services. Thanos is a sidecar to the sidecar. And what Thanos is doing is it's kind of getting ready for when people do a query from Grafana, right? It goes through, Trickster basically allows it to do some caching, but goes to Thanos. Thanos then goes and farms this information from the different Promethei, brings it together into S3. Thanos compactor then optimizes it. Again, it's all TSDB, but it doesn't have to be S3. It could be any of those other stores. So this process, again, to the outside observer, doesn't look any different than if they were just talking to Prometheus, because it's using the same PromQL. The only difference between the major difference is instead of Cortex grabbing data and bringing it together ahead of time, Thanos gets it at query time, but ultimately stores it in a distributed blob storage. It doesn't necessarily solve the problem of fast query, right? It just cares about long-term storage. The Thanos architecture, so, again, as I mentioned, there's a Thanos sidecar, that's running with Prometheus, right? And it's constantly putting data into the object storage. And then there's a process that does this compaction, does the chunking and downsampling so that it's easier for people to ask a question and get the data quickly. But when people use it, they're using the Thanos query to go and retrieve it from the object storage. And sorry, first it goes to the object storage. If it doesn't get it, then the system has to go to the Prometheus, grab it, bring it, and then it returns it. The Thanos ruler basically is responsible for the alerts, right? It takes care of how do I want the alert. Here's an example from Bonsai where they're running, let's say, Drupal on Kubernetes. There's the Prometheus operator that's running. There's a Prometheus server, and next to Prometheus is Thanos. And it's kind of in the back end, it's doing all of this. And this continues to scale as your apps continue to scale. As long as you have Thanos sitting next to Prometheus, it continues to scale. The query process in Thanos is, first it goes and sees if it has information, right? And if it doesn't, then it goes to the Prometheus services, gets it, merges it, dedupes it, and brings it back. In this time, it goes ahead and stores it into its long-term storage. Right here. Gets it, stores it, brings it back. Okay. Now, Cortex is actually part of the Grafana labs, the people that are primarily responsible for Prometheus. People from the Grafana, sorry, the Prometheus project started to make Cortex. The people that started Thanos also used to work on Prometheus. Now, Thanos and Cortex committers are really working together. So here's an example where the Cortex, is using some code from Thanos to get data into the buckets and compacting it using the Thanos compactor and using the Thanos bucket store for the cold storage. So it's not like these are mutually exclusive. And in fact, I think in the future, as many people have assumed or presumed, is that eventually these projects are going to become more and more closer together because they solve different problems. One is taking care of when I want to query at that moment, I want to get everything from all the nodes. What does that look like? Whereas Cortex is constantly bringing data together. It may not be immediately, relevant. So yeah, it's a very interesting competition or a co-opetition. They're both cooperating. They're both kind of solving the same problem. And I'll bring up the website so we can see like who's using this stuff, right? And we'll take a look at some other reference diagrams. The resources I put here, I'll keep adding to it before we publish the blog post. But the majority of the stuff that I came up with is really a matter of like looking at the Thanos website, looking at the Cortex website. There's a couple of other, we can also go to the GitHub pages for each of those. But what I would want to show you is if we take a look at Cortex. Right, so you're in good company, yeah. In fact, Weaveworks basically provides this as a service. DigitalOcean used to have their own, Vulkan, Prometheus clone or implementation. Now they use Cortex. What, again, you'll see is the same things, right? Long-term storage, from QL, global view, horizontally scalable. Now let's look at Thanos. Global query, long-term storage, Prometheus compliant, and then maybe slightly something different about downsampling and compaction. but it's the same. From the end user, it looks the same. It's just, it's implemented differently. Who's using it? A lot of people are using it. And I wouldn't say that, just because they have more logos, that Thanos is better. It's just that you could have a really small company using it. Like, oh, wow, there's another logo here. So I look at this stuff with a grain of salt. Let's see, I know Talend. I know TIDB. TIDB is a new SQL version of MySQL. I know Zing. So I know some of these companies are actually pretty big company. Tencent, there we go. So Tencent is a cloud company. So Tencent uses this versus Cortex or AWS, for example, uses or provides Prometheus at scale using Cortex. And as promised, I wanted to show you M3DB, which I didn't get to in the earlier reason because I just didn't see as much community talk. It's definitely there. So Uber's using it, LinkedIn, Walmart. I mean, these are not chump change, right? Databricks. Tencent's also using it. So again, it's not like a mutually exclusive thing. What does M3DB do? It does the same thing. Prometheus sends data into M3, Grafana picks it up. Global scale, yeah, reliable, compatible with Prometheus query language. Let's see, performant, right? Same general things. And I think what I wanted to show was the architecture, how it's slightly different. I'd seen it before. There we go. Let's see. So actually, it's inspired by Cassandra, but I don't think it uses Cassandra. I think it ends up storing its own data. I'm trying to show the storage engine here. It basically makes its own database, right? Similar to Cassandra, which is great. But I'm a big fan of don't reinvent the wheel. I know Uber probably had a pretty good reason for doing this, but I wouldn't know, why they had to rebuild basically a database to be like Cassandra. But we can take a look again, and I love Google Images, gets you everything you're looking for. Yeah, so M3DB it's kind of its own database that is architecturally seems to be very similar to Thanos or Cortex. I think it's more like Cortex in that it aggregates data and it essentially stores data for you, and then the M3 query gets it. So again, maybe I could have really talked about it, but that's it. It's a slightly different technology, but it does the same thing as Thanos and Cortex. There's one deck that I wanted to show. Let's see. And so looking at, there we go. This is the deck where I got inspiration for this talk. Yeah, so like, Thanos, query time, deduplication, Cortex, dedupes when you write it. Thanos stores data on S3 as it pulls it. Cortex stores it at the pull time in this in the NoSQL database. And then I think, yeah, there's another picture which I don't see here, but basically shows how Thanos and Cortex could be used together, and eventually maybe even merge. Right? They're just kind of two sides of the same coin. But yeah, that's it. Any questions about what we covered today in terms of Thanos, Cortex, Prometheus? Love to hear your thoughts. And I'm going to go ahead and turn this off. Cool. No questions. I'm game. We can wrap up early. Okay. Any topics that everybody wants to talk about in terms of data? Just like an open forum for a bit. If not, we can wrap up, and we'll see you guys next week. Next week we are talking about. I believe we're talking about. Let's see. Pandas. That's right. Pandas.
Oh, pandas.
There we go. For data engineering. Yeah. Awesome.
Nice.
Very cool. And yeah, thanks everybody for joining us. You all have a wonderful rest of the day. We'll see you all next week, same time, same place. Take care.
Thanks, Rule.
Thanks, Mike. Take care.